I don't see any notes up here. Those would be very helpful. My name is Steve Mills. I'm technical lead at Facebook, and like Bill was saying, I also lead the Rack and Power project for OCP as well. OpenRack v3 is the next generation of OpenRack architecture that we just started working on earlier this year. Today I'm going to talk about how we're engaging with the Rack and Power project to enable collaboration across the OCP community. Here's what I'm going to be covering today. So when I'm done, you should have a better idea of what new features are going to be incorporated into OpenRack v3, how we are engaging with the larger OCP community, and you should have a good idea of what is coming next in the short term. So let's begin with why OpenRack v3. So over the last 30 years, we've been blessed with the rapid expansion of the capabilities of the technologies on which we all rely. However, almost everyone in this room is coming up against barriers that relate to fundamental constraints of physics. So these are problems at the atomic level. It's foreign territory, and it's increasingly even more expensive for us to explore. So component makers will still be able to make improvements, but it will require research and development spending increases in order to achieve these gains. So one way to limit the risks and costs associated with taking these next steps is to share these with other interested parties, and that is where OCP comes in. So Facebook and others see the value of building infrastructure on a common platform. And so hopefully that's where OpenRack v3 will be able to help out. So originally Facebook's v1 and v2 platform were developed internally inside of Facebook, and then they were open sourced to the community late in the development process. So the features for these architectures were singularly focused on Facebook's needs. With OpenRack v3, we aim to enable adoption across the OCP community by providing a platform that many users can use to build solutions that work best for them. So by developing a common frame, we should be able to generate larger volumes, add features, and reduce costs all at the same time. But to do so, we need to provide flexibility that enables optional features so users can tailor the solution to their specific needs. So we hope to do the same thing with the power architecture for v3 by providing a solution that covers a wide range of applications, not just Facebook's. And finally, we have many new and interesting technologies that are currently in development in Open Compute's advanced cooling solution projects. So OpenRack v3 will provide a platform where we can integrate all these new developments into the larger OpenRack architecture. So finally, let's talk about what new features we'll be adding to OpenRack v3. So I'm going to show you a list of features that are new to OpenRack v3. Many of these are being driven by the community rather than just what Facebook needs. So to begin with, this is one of the more interesting features that we're adding, and that's support for both OpenRack's 48mm vertical spacing and the 19-inch EIA vertical spacing. So this will allow users that are currently using EIA racks to build rack configurations with the same densities on the OpenRack platform. So this particular feature was a request from both Microsoft and Baidu that we add this feature in. So to be clear, we're not supporting the EIA widths, only the vertical spacing. So we're also going to be increasing the dynamic load rating of the rack from 1,400 kilograms to 1,600 kilograms. And we'll also be increasing the height from 41 OpenU to 44 OpenU, which translates to 48 EIA RUs. So the cable manager that's part of OpenRack v2 is integrated directly into the structural frame of the rack. So for v3, we're going to be taking that out of the structural frame and making it an optional kit. This will allow users to customize that particular solution around their needs. We will also be integrating the blind mate liquid manifold that's currently in development in the advanced cooling solutions subgroup. So that'll be a nice feature as we go forward. And we're also going to be similarly introducing a rear hot plug data fabric as well. So this optional kit, but the hot plug data plane, I could see there's probably 3 different configurations that seem probable, and one's a high-speed copper, a high-speed optical, and a low-speed copper management bus. So we'll kind of see how this progresses as we go forward. So in addition to the air containment that we had on V2, the side panels for the rack will also provide a security feature as well. So this will help deployment of OpenRack into co-locations. So similarly, the security door, both front and back, will be for that similar need. Along with the security door, we'll also be adding in the features for both front and rear door heat exchangers. This is also currently in development within the advanced cooling solution sub-projects. The bus bar voltage that we supported for V2 is 12 volt. We will be supportive of a 12 volt or 48 volt option within the architecture for OpenRack V3, but Facebook will only be developing power systems to support the 48 volt version. The power shelf on the V2 solution integrated both the power and the BBU into a single unit. As we go forward for V3, we're going to be disconnecting the power shelf and the BBU into separate shelves. So this will provide one other thing about the power shelf location is that we also had it fixed within the rack. And the reason it was fixed locations within the rack is because we had bolts that were used to attach the output of the power shelf into the rack. So for V3, we'll also be changing that from a bolted interconnect to a connectorized solution. By changing it to a connectorized solution, you'll be able to install a power shelf anywhere within the rack vertically. So that makes it much easier to build out custom configurations with that kind of flexibility. Again, as we separate the power shelf and the BBU, that adds 2 features. So one, it adds a lot of flexibility to introduce as many BBUs as you need. So this will size the backup time based on different configurations, so your BBU capacity is only deployed where needed. And secondly, it also improves the reliability of the overall system by moving the controllers into the BBUs rather than relying on the PSUs like the V2 solution. So we'll be also adding in the peak power shaving as a feature. And we'll also be developing a universal power shelf input connector. So this will be a direct connection between the whip and the back of the power shelf. So standardizing on this has been a request from the Rack and Power team for quite a while. So historically, Facebook has used a 5-pin input into the back of the power shelf. We'll be going to a 7-pin input into the power shelf, and this allows us to remove the PDUs that are part of the configuration. So that'll reduce the number of L11 rack configurations that we have to support. So this is a feature that you saw earlier that's part of the Microsoft Olympus architecture that we're porting into the OpenRack architecture. Going forward, we'll be going down to a single power zone from the 2 that we've got on the V2. So the architecture would still be able to support more than 1 power zone if users wanted to do that, but Facebook will be deploying mostly just a single power zone. So let's next talk about how we're engaging with the OCP community on this. So collaboration is an important part of the Facebook culture, and so working closely with industry partners is a natural extension to the way we work and why we focus on open engagements with so many of our industry partners. As a founding member of Open Compute, Facebook has a long history of contributions to the community. So OpenRack v3 will continue to follow in this tradition. So let's take a quick look at the specifications that are under development right now for this particular architecture. To begin with, the 48-volt bus bar and the 48-volt IT gear power connector. So that's the connector that goes in between, say, a server or a storage component plugging into the bus bar. So those two components, that connector and the bus bar, are already defined as inside the Open Rack specification. So we're hoping we could use these as is. We have another specification that is part of a joint development agreement group that's defining the V3 frame and will incorporate a lot of the features that I previously discussed. We also have a specification running on the hot pluggable rear liquid cooling manifold from ACS, as we discussed. And if we zoom in here a little bit on the power shelf, there's quite a few specifications that are defining the power architecture. To begin with, we've got the power shelf itself, which will have a specification associated with it. The power supply unit and the shelf management controller that go inside the shelf will each have a specification for them. We also have a power shelf 48-volt output connector. So this will be a high amperage interconnect between the shelf and the bus bar. So this is essentially what's going to allow the power shelf to be installed anywhere along the bus bar. And then finally, we will have a universal 7-pin input connector for the whip. So each of these lines that I just presented is an independent specification that is currently under development in the Open Rack and Power project. So this isn't a complete listing of all the stuff that we've got currently for Open Rack v3, and I'm quite confident we'll be adding some more to this here in the near future. So let's go through what is going on next. So the next thing we've got is a face-to-face engineering workshop that is planned for next month. It's going to be a combined workshop consisting of the Rack and Power project, all three of the Advanced Cooling Solution sub-projects, as well as the Data Center Facilities project. There are two primary goals for this workshop. So the first one is we want to drive consistent requirements between all of the specifications that are currently under development in the Rack and Power, Advanced Cooling Solution, and Data Center Facilities. So we want these specifications to provide consistent and interchangeable method to move the heat from the surface of the cold plate until it exits the data center. The second thing is we want to kickstart all of the specifications that are related to the power architecture. So far, we haven't had any engagement yet publicly within OCP, and so this is a great opportunity for those that are interested to help us make some progress on that. So if there's any of the topics I've talked about today that are interesting to you, we would love to have you join us and work on the details of the specifications that I just covered. As we make progress, of course, all of the specifications will be posted on the wiki for review and comment from the larger OCP community. So we'd really appreciate your feedback as we make progress. And if you would like to get more involved, the best way to do that is to join the mailing list for Rack and Power as well as for Advanced Cooling Solutions. That way you'll have updates on what the agenda is going to be and the topics that we're going to be talking about coming up. So that's all I've got today. So thank you very much. I appreciate it.
Hey, thank you, Steve.
Yeah, you bet.
Hey, does everybody know what ACS is?
I would doubt that.
Huh?
I doubt that.
Why don't you tell us the three projects.
Sure. So ACS stands for the Advanced Cooling Solution. So these are three sub-projects that are underneath Rack and Power in the OCP larger organization. Yep. So there's three different projects. One, we've got immersion. We have the rear door heat exchangers, or it's not just rear door. We both have front and rear heat exchanger doors that are in process. And there's also a cold plate group as well.
And the cold plate is really focused on, right now, on defining a dripless connection that's easy to integrate into your rack and easy to integrate into or hot plug your node.
Exactly.
Right, blind mate. And then the idea is that as a core technology, as an interface, can be adopted by any of these rack architectures or any other projects outside of OCP.
Exactly. So the primary goal for all three of the sub-projects is that we are focusing on interchangeability and open source. So a lot of these technologies have been around for a very, very long time. But the idea of making them open sourced and interchangeable allows us to build scale, which is something that is new to this particular area. So we are starting with the interfaces between the manifold and the IT gear. So once we get those defined, we can start working our way up to cold plates and the other thing. But that's originally where we're focused our time right now.
So a lot of great work going on by Steve and the Rack and Power group. He mentioned a workshop coming up in July, and obviously that would be difficult for people to attend. Just to let everybody know, we record all of our workshops. In some cases, we live stream them. In this case, it will be recorded, and all the presentations and the recordings will be posted immediately afterwards. And so our China community can view those on a reasonable time schedule, not in the middle of the night.
Yes. So for this particular workshop, we're going to have very few presentations, though, where it's only a couple of hours. Most of the time is really going to be focused on collaboratively sitting down and writing the specifications. So as opposed to showing what we're going to be doing, we're going to be sitting down and doing all the hard work, actually writing the detailed specifications out. So we're going to see how much progress we can make.
So everything we do is recorded. You're welcome to go onto the web portal and past events, and you can sit and watch all of it. Social media plays a big role in this community, and particularly as we operate around the globe. Today's presentations is being live streamed over WeChat, and I understand we had 190,000 viewers earlier today.
All right, that's wonderful.
Anyway, good. Thank you very much.
Yeah, thank you.
Okay, thank you, Bill. Thank you, Steve.